Serving industry for over a century, Whiting has been instrumental in the development of the drop table concept, and is responsible for many of the added values and practical features found in today's modern maintenance systems. Rail and transit equipment require frequent removal of wheels and trucks, or temporary lowering and jacking of these parts, representing a loss of revenue in layup time. With the Whiting drop table, the layup times are drastically lowered in performing such tasks. To remove drive wheels or trucks with a drop table, the locomotive is located and supported over the table top, where the trucks or wheels are disconnected, lowered, transferred laterally, and raised to a release track. The trucks can be then moved to a maintenance area where inspection and repair can then be performed quickly and efficiently. Each Whiting drop table is designed to meet a specific application. Our experience enables us to incorporate proven standardized components into the unique design, which lowers the original cost and impacts favorably on the future repair costs. Body supports are a very important part of a drop table system. Whiting have designed 8 styles of body supports. Therefore, there is at least one to satisfy any requirements. For example, this drop table is equipped with an HVL body support. The HVL body supports are used to support one end of a locomotive over the drop table during removal and replacement of a locomotive truck or wheel set. Each body support is wheel-mounted and travels on and is guided by structural girders mounted on columns which parallel the drop table rails at the service track. The support beams are manually operated. Here is how the steps of operation of a Whiting drop table assist in the rendering of fast maintenance service. Step 1. The locomotive enters the shop and is driven directly over the drop table. Then one of the 8 possible styles of body supports is positioned under the locomotive, or truck blocks are placed under the bolster. The drop table is then raised slightly, a short distance to facilitate disengaging the locking bars. The locking bars are manually disengaged from pockets embedded in the pit walls. The drop table is then lowered slightly, a short distance, to facilitate disconnecting power leads. After disconnecting, the truck or wheel assembly is lowered on the table. The lifting beam trips the lower limit switch, which stops downward movement of the hoist. The table is then racked into position to the release track, so the truck or wheel set can be raised or rolled onto the release track for repair. Various types of release track covers are available. In this drop table design, the release track is covered with a hinged bascule design cover. It is a 2-piece structure divided along the center line of the track. The 2 pieces are hinged at opposite sides of the pit. Spacer posts, separate from the release top, are set in guides embedded in the pit walls. They are movable in the guides and fitted with roller assemblies at the upper ends. The cover design eliminates superstructure, enabling the truck to be removed by an overhead crane, and covers the pit when not in use. Once the table has fully lowered, the table is then racked towards the service track with the new or repaired trucks. The control and power cables are automatically recoiled onto the carriage unit on return. The Whiting drop table uses self-locking worm screws to raise and lower its service tops. This ensures that even in the event of a power failure, the table will remain stationary. Furthermore, the drop table is equipped with limit switches to prevent over-raising, lowering, and racking for perfect alignments every time. Once again, the table is raised to facilitate locking bars for the safe reattachment of the trucks. Whiting drop tables are engineered for rugged service, low maintenance, and with ample safety factors, so they can perform on demand. The conservative design philosophy is base up, with all components loaded under compression. Shear and tensile design is avoided wherever practical to minimize the potential for failure. With the use of improved materials and processes, the evolved safety factors are far in excess of industry standards.